Hello everyone. Apply the Kirchhoff's rule and find the current passing through ED, AB and BE. In this diagram, the direction of current in each loop is not shown here. Okay. So we have to guess here what is the current passing through each branch. So you can look at this point here. This is a 50-volt battery is the or 50-volt cell is the. It supplies a current of say it as I1 current. Okay, so if the 50-volt supply I1 current through this 2 ohm is also I1 current, and through C2B is also I1 current, and after that we don't know. Alright, because other cells also connected here. Look at the second cell here, 30-volt cell. This also provides a current. We don't know what is the current, so we are just taking it as the current I2. So if this is the I2, definitely through 2 ohm is also I2 current. And of course, if it is starting from I2, definitely it ending is also is I2, right? Next one, there is one more cell is there, that is a 10-volt cell. So just imagine the current coming from the 10-volt cell is equal to I3. Okay, and we can imagine that if this is the I3 is starting from the 10 volt, definitely it should reach here also I3 current, right? So current passing through 1 ohm is also I3. B to A, that is also I3 current only. So we have now got the clear concept of current passing through each arm. Now we have to use the Kirchhoff's rule. First of all, we can use here at the E, the junction E. At the junction E, what is the current rule we can apply here? Current entering into the junction is equal to current leaving the junction. What is the current entering here? Current entering, you can see here I2 is the current entering and I3 also entering, which is equal to current leaving the junction, which is equal to I1. Say it as the equation number 1. Now look at the each loop. Let's take the first loop is equal to FEBAF. That means this loop. We can consider this loop. Okay. So next loop we are considering here loop FEBAF. So now let's use the loop rule and write the equation. Now you are considering here the clockwise. So we can start from the point A. So if we start from the point A, we can write here it is equal to minus I3 into 1 ohm, because you can see here if you are going in clockwise, the current is also flowing in the same direction. We can take it as a negative. All right, the negative potential drop. So minus I3 into 1. Next one, the cell is coming there from F to E. So if you are considering you are moving in a clockwise and you are moving through the cell is negative to positive, that can be taken as positive. So we can write the plus 10 volt. Next one is from E to B. Look at that one. So you are going from E to B, but the current is flowing in opposite direction. So you can take it as a plus value. So we can write the 2I2. Same way here also 30 volt is there, but you are going from positive to negative terminal inside the cell, so can be taken as a minus, that is minus 30, which must be equal to 0. There is no other potential drop here. So we got the equation here minus I3, all right, then plus 2I2 minus 20 equal to 0. So what is the equation you got now? 2I2 minus I3 is equal to 20. You can write this is the equation number 2. Now take the next loop. What is the next loop? Consider the loop EDCBE, and also you can consider this is in a clockwise direction as a sign convention. So we can write here next one is loop EDCBE. Once again you are taking the sign convention clockwise direction. Just start from the point E. So we can write the, so coming again negative to positive, so we can consider here plus 50 volt. Now from D to C, you can see here it is current in the same direction of the sign convention, so we can write the minus 2I1. C to B, there is no potential drop. Now B to E, you can see there is a cell is there, that is negative to positive in the same direction. We can take it as plus 30 volt. Now what is the potential drop across the 2 ohm? That is in the same direction of the current supply. So we can take it as the minus 2i2. Minus 2i2 is equal to 0. So what is equation become now? We can write here minus 2i1 minus 2i2. Now 50 plus 30, 80 plus 80 is equal to 0. Or we can simply write here 2i1 plus 2i2 is equal to 80, or I1 plus I2 which is equal to 40. Equation number 3. Alright, equation number 3. I1 plus I2 which is equal to 40. Now it's a time to solve it. When you are solving 2 and 3, you can see I2, I3, I1, I2. Three different variables are there. So in order to avoid that one, you can substitute in equation number 2 2i2 minus, what is i3? I3 you can take from the equation number 1. I3 is equal to I1 minus I2. Substitute here. What is equation become? Minus I1 minus I2 which is equal to, what is equation number 2 remaining one? 20. So that is equal to 2i2 minus I1 minus minus plus I2. So 3i2 minus I1. So we can write here minus I1 plus 3i2 which is equal to 20. Which is equal to 20. We can write that equation number 4. Now look at the equation number 3 and 4. You can compare or you can simply solve it by adding. So equation number 3 plus equation number 4, you will be getting now, look at this one, minus I1 plus I1, 0. Remaining one is you getting 4I2 which is equal to 60. So I2 is equal to 60 by 4 which is equal to 15 ampere. So you got I2 equal to 15 ampere. Okay. So you can easily calculate in the equation number 3 or 4. If you use equation number 3, I1 is equal to, alright, 40 minus I2. I2 is 15. So you'll be getting what? 25 ampere. So I1 is equal to 25 ampere. If I1 is 25, I2 is 15, what is I3 equal to? 25 minus 15. Right? I3 equal to I1 minus I2. So 25 minus 15. So you'll be getting here I3 is equal to 10 ampere. Alright. Now what was the question? Current passing through ED, AB and BE. ED, look at the ED. ED, the current is passing is I1, right? So we can write the current passing through ED which is equal to I1, that is equal to 25 ampere. Next one is AB. Look at the diagram. AB. Through AB, what is the current is flowing here? That is the I3. What is I3 here? 10 ampere. And last one is BE. Look at the diagram BE. So current passing through the BE is I2. I2 is equal to what? 15 ampere. So across the BE we can write the word 15 ampere. So this is a way to apply the Kirchhoff's rule, and we got the answer here. I hope you understood this one. Thank you.